So for number 1, I am going to replace the sine squared x with the information from the identity. So I'm going to use sine squared x plus cosine squared x equals 1. I'm going to rearrange it and solve for sine. So I'm going to move the cosine over, and I get sine squared x is equal to 1 minus cosine squared x. So I'm going to replace that. So I'm going to put tangent squared x here, and then I'm going to put 1 minus cosine squared x. I'm going to distribute tangent to the 1 and to the cosine. So I'm going to get tangent squared x minus tangent squared x times cosine squared x. Yes?
Where'd you get the 1 from in the original equation?
Right here?
No.
This is what you memorize. This is one of the identities. Okay? And then I've just rearranged it and solved it for sine. Okay? So now I'm going to replace this tangent with sine squared over cosine squared. So sine squared x, so that's what I'm replacing, over cosine squared x times the cosine squared x. Now I still have this green tangent squared x here in the front. I'm going to simplify the red, and now I'm left with tangent squared x minus sine squared x. Everybody with me so far? All right. Now again, if you remember what sine squared equals, it equals this 1 minus cosine. So I'm going to go ahead and plug that in there. So tangent, the green, let me do it in green. So the green stays there. And then the minus sign is here. And then I'm putting in 1 minus cosine squared x. And then I can distribute the negative sign or the subtraction sign. So this will become a -1. This becomes a positive cosine squared x. And then I still had the green. So now if I just flip it around, it's exactly what I was trying to prove, which was tangent squared x plus cosine squared x minus 1. So that was the whole right side. It checked. So that is one way that you could have done that. Now I saw some people replacing tangent with sine and cosines. You can. It just needs to flow logically. So this is one way to verify this identity. Okay, everybody work on number 2 now. For number 2, the first thing I'm going to do is FOIL the numerator. So once I FOIL that binomial, I'm going to end up getting secant squared theta. And then outer and inner is going to give me -2 secant theta tangent theta. And then the last term will be positive tangent squared theta. And then I still have the +1. From my denominator, I'm going to pull out a GCF of cosecant. So I'm going to factor out a GCF of cosecant theta. So in the denominator, what will be left will be secant theta minus tangent theta. Now for the numerator, the black, notice this end here is actually one of your identities. I'm going to change tangent squared theta into secant squared theta. Tangent squared theta plus 1 is equal to secant squared theta. This is a Pythagorean identity. So I change this one into secant squared theta. I'm going to pull out a GCF of, actually first, I am going to combine my secants. So notice I have a like term here with secant squared and secant squared theta. So I'm going to add those. So those are like terms. So I'm going to actually make this 2 secant squared theta minus the black that's left there. And now I can pull out a GCF out of the top. Let me rewrite the bottom. So the denominator for now is staying the same. So cosecant theta, and then the secant theta minus tan theta, that's staying the same. I'm going to pull a GCF out of my numerator. My GCF is going to be 2 secant theta. So I'm going to pull out 1 from each one, the green term and 1 out of the black term. So out of the green term, what's left is 1 of the secant thetas, and then out of the black, the tangent theta's left. Notice now I can cancel it with the blue denominator. So let me rewrite the denominator. So now I can cancel this with this. So now I'm left with 2 secant theta over cosecant theta. I'm going to turn these into sines and cosines. So the red is going to become 2 times 1 over cosine theta. And then the denominator, the blue, is going to become 1 over sine theta. So I'm going to simplify the red. The red is actually going to become 2 over cosine theta. And I'm going to divide that by the denominator. So this denominator, I'm going to flip it to the reciprocal. And now I can multiply. So now I'm left with 2 sine theta over cosine theta. And this right here is tangent. And that's what I was looking for. So 2 times tan of theta. And that's what I was trying to prove. So I got there. I'll zoom out. And that was number 2. Now, for number 3, I'm going to actually FOIL this right side. So that way, when I simplify my left side, I'm going to look for the FOILed answer. So when I FOIL this, or multiply it by itself, I'm going to end up with cotangent squared. Cotangent squared x. And then the middle term is going to be negative 2 cotangent x, cosecant x. And then the last term is going to be cosecant squared x. So that's what I'm going to end up getting to. So over here, I'm going to multiply the numerator and the denominator by the conjugate. And the conjugate is 1 minus cosine x. So I'm going to FOIL the top and the bottom. So when I FOIL the top, I'm going to end up with 1 minus 2 cosine x plus cosine squared x. That's the top FOILed. The bottom, remember when you multiply something by its conjugate, all you need to do is first and last. So it'll become 1 minus cosine squared x. Now, whenever we use that conjugate, it's always going to produce some kind of Pythagorean identity, some form of it. And this is actually the form, the identity sine squared x plus cosine squared x equals 1. I'm going to rearrange it. So I'm going to move the cosine over. And you're going to see that it's going to equal sine squared x. So sine squared x is equal to 1 minus cosine squared x, and that's what I'm going to replace the blue denominator with. So the top, I'm going to actually, let me just rewrite it in red for now. So 1 minus 2 cosine x plus cosine squared x, and this is going to be over sine squared x. Now what I'm going to do, because I'm trying to make it into this 3 terms, so let me make each one a color. I'm going to pull this fraction apart and give each one of my red terms a denominator of sine squared x. So I'm going to do the 1, it's going to go over sine squared x. Then the middle, it's going to become the blue. So negative 2 cosine x over sine squared x. And then the end, I'm going to do in red. So that's going to be cosine squared x over sine squared x. Now the red and the green are obvious. That's going to give me my tangent, my cotangent. So the red end produces the cotangent squared x. The green is going to give me my cosecant squared x. And now the blue, this middle term here, let me do this in blue. I'm going to pull this fraction apart. So think of this as the answer to a multiplication problem. I'm going to separate the sine squared into sine times sine. And then the numerator is negative 2 cosine x over 1. So I'm pulling this apart and making it 2 separate fractions. And now I'm going to simplify that. This is going to turn into 1 over sine is going to be the cosecant that I'm looking for. And then negative 2 over cosine x sine x, that's going to produce my cotangent. And it's got the negative 2. So now I'm going to drop down the green, drop down the red, and then put everything with it. So this is going to become cosecant squared x minus 2 cotangent cosecant x plus cotangent squared x. Now, over here where I foiled it, the black, I'm just going to flip it around. I can put this at the back and this at the front, and then it looks the same. So if I write it as cotangent squared x, because it's positive, then the middle term, I'll leave it there. And then I'll write the cosecant at the back. And it looks exactly like what I had when I foiled it. So it checks. I could factor it so it's a binomial squared. But again, you can simplify that right side a little bit so it looks like something you want. So if you want to foil it, you can. Or you could factor this so it looks like what was originally given to you. Or what I'm going to do is I'm going to change my left side, and I'm going to change all of my things into sines and cosines. So I'm going to change the cosecant first. I'm going to make this 1 over sine. I'm going to change the cotangent, and I'm going to make that cosine over sine. I'm going to also work with the denominator, and I'm going to turn tangent into sine x over cosine x. Then the sine x is going to stay. Now, I need to simplify both the numerator and the denominator. So the numerator, it's already got a common denominator, So it's going to become 1 plus cosine x over sine x. And this needs an x here. Then for the bottom, that one, when I simplify it, I need to make this have a common denominator of cosine. Denominator.
Are you doing both problems?
Probably, so I can get the video done. All right, so for the denominator, my common denominator here is going to be cosine. So I need to multiply this one by cosine x. So then over here, this one is still sine x over cosine x. This one is going to become sine x, cosine x. Sorry, my stylist here is bad. Let me fix this. Oops, let's not erase. So this will become cosine x over cosine x. So then I can add my numerator here. And this is going to become, so this is the denominator. So now on the top, I have 1 plus cosine x over sine x. The bottom is sine x plus sine x cosine x over cosine x. So that's this. So now I can do a keep flip change. So really what I'm going to do here now is 1 plus cosine x over sine x. I'm dividing it by this thing. So I'm going to flip it to its reciprocal. Sine x plus sine x cosine x. Now out of the red, notice right here, I can factor out a GCF of sine x. So let me leave this one alone. Then I'm going to leave this numerator alone. When I pull out sine x as a GCF, I'm left with 1 plus cosine x, which is going to cancel with this one. So now I have 1 over sine x times cosine x over sine x. And notice what I was trying to make it into was cosecant x, which is this, times cotangent x, which is this. Now they have it flipped around. Remember, multiplication is commutative, so I can write it as cotangent x, cosecant x, which is what I was trying to prove. So that checked. Then number 5. Was that 5? That was 4. Okay, so now number 5. For this one, I'm going to simplify the left side. One, I am going to realize that the denominator is actually an identity. I know that cotangent squared plus 1 is equal to cosecant. So let me leave the cotangent squared x minus 1 alone for right now. I'm going to change this to cosecant squared x. And now what I'm going to do is I'm going to divide. So I'm going to set it up as cotangent squared x minus 1 divided by cosecant squared x. I'm going to turn cosecant into its reciprocal, which is 1 over sine. And I'm also going to change cosecant or cotangent into its reciprocal. So this is cosine squared x over sine squared x minus 1. And I'm going to divide that by 1 over sine squared x. Now over here, I need to really, when I'm dividing this, it's really multiply by the reciprocal. So I'm going to distribute sine squared x to both of these terms. So I'm going to distribute the sine squared to here and to here. When I distribute it to the first one, it's going to cancel the denominator. So I'm going to be left with cosine squared x minus, and then when I distribute it to the -1, it'll be sine squared x. Now I'm also going to use this identity again that I used a bunch of times before, the sine squared x plus cosine squared x equals 1. I'm going to solve it for cosine. So I'm going to move this over. So sine squared x over. So cosine squared x, I'm just showing you how I'm going to use it. 1 minus sine squared x. I'm going to replace this cosine with this. So now it's going to become 1 minus sine squared x minus sine squared x. And then now I've got 2 of them here. So 1 minus 2 sine squared x. And that's what is on my right side, and it checks. Bye.